on the this line are L. L is the from origin to this point length L, and let me take this point is y coordinate is by 1. Let me take y1 here. Coordinates of A are L and y1. Okay. Now what is the point? What does it say? PA equal to L here. It's PA. So L is this length. Now we have to find out what L and y1 are lying on the ellipse here. So L and y1, A point, this is A point here. A, L and y1 are lying on the ellipse. Lying on the ellipse. Therefore, we can find out y square upon a x square. So y square, if I calculate, so y1 square upon v square is equal to 1 minus x square. X square is here L square. So L square upon a square. That means this is a square minus L square upon a square. So y1 is equal to under root of b upon a. Or if I write y1 square, then square is there. Y1 is b upon a under root a square minus L square. Is the value of y1 here. This coordinate here, y1. Y1 will be substituted like this, the length of this point. Okay, now point is what we have to find out. It says that find the volume of the solid generator which remains after subtracting this cylindrical portion out of this solid. Cylindrical portion is this much. This whole cylindrical portion, but the cylindrical portion obtained, this cylinder is this from this point A, B point, this point. Okay, but this arc is away from this circle, this cylinder. So we have to find out what is the length of the volume generated by arc AE and this arc DE dash, the same thing. That length, that twice of that, we have to find out what is the volume generated by AE, the arc, that plus volume of the cylinder will be subtracted from the whole volume of the ellipse. Okay, which is obtained by the spheroid. Volume of the ellipse revolved about the axis or x or major axis. That is the spheroid. Total spheroid's volume minus volume of this cylinder plus twice of this arc and this arc, they will generate some extra value here. Let me just find out this point. This arc is away from this cylinder. So arc length is, and up to this point, this is cylinder, radius of cylinder is by 1. Radius of cylinder is by 1 here. Okay, and this arc length is this AE, this A point, E point. This arc will extra generate volume. Okay, that will be obtained by revolving this arc and giving this limit, or the limits for this up to this L to A. L to A will be the limit for this arc volume generated by the arc. Okay, that's the point. So let me find out what the solution here. Solution: the volume of the remaining solid generated will be volume of the spheroid, complete spheroid, volume of the spheroid obtained by revolving the ellipse. This is known as, okay, by ellipse, revolving the ellipse about major axis, minus volume of the cylinder, having total length twice L and radius by 1. Volume of the cylinder having radius by 1, I'll just define that what is by 1 is this value, by 1, and length or width of this length twice L plus 2 times volume generated by arc, 2 times volume generated by arc AE about the major axis, about the major axis. That is the total volume will remain. That volume we have to find out. Now each and every item we have to find out the volume of the cylinder here, what the volume of this arc generated by arc AE, this twice of this, because the DE dash will also be the arc that will also generate some volume. Okay, and the volume of the cylinder is this, having length twice, total 2L. So first volume of the cylinder let me find out, and volume of the cylinder and volume of this arc that will be subtracted from total volume of the ellipse that we will calculate, because total volume of the ellipse we calculated in the previous lecture series as 4 by 3 pi a into b square. I just calculate this, so that will give us the total volume. The remaining volume we have to find out the remaining volume. Okay, each and everything that we now calculate today, each and everything here. So in this case, volume of the cylinder, volume of the cylinder which is DD dash or ADC dash B, ADC dash this B. Okay, here I have taken C only, so it is now dash ADCB. I have taken like this. ADCB is equal to this is pi into this whole length is y1 square here. y1 square is radius, pi into y1 square into AD. y1 square is pi into, what is y1 square we calculated, it was b square upon a square, in bracket it was a square minus l square, because in terms of l and y1 we calculated from the given equation, because here y square equal to b square upon a square into a square minus x square. X is here l. In this case AD is twice l. This AD, total length of the cylinder, is twice L. It is giving us pi into, okay, twice pi into b square L upon a square. In bracket it is a square minus L. This is value of volume of cylinder. This is the first equation, because this will be subtracted. So volume of the cylinder we have taken, which is drilled out, which is cut out from the whole spheroid, okay, whole solid generated after revolving the ellipse. Okay, this is prolate, is known as prolate cylinder, prolate spheroid. The prolate is spheroid and oblate is spheroid. We just find about prolate spheroid was when ellipse is revolved about its major axis. Oblate was when the minor axis about minor axis. When ellipse is revolved about minor axis, and it is oblate spheroid, and prolate spheroid is this, when they are revolving the ellipse about its major axis. That is prolate spheroid. In this case, volume of the cylinder is equal to this. Let me write it here: 2 pi into b square L upon a square. I'm sorry. This is upon a square into a square minus L square. This is the volume cylinder of the volume of the cylinder. Now let me find out what is the volume of this arc. Volume of the solid generated by arc generated by arc dA, sorry, in this case AE, arc A, this is twice of this, so this is equal to twice. Now in this case limits are L to A, total length 0 to E, sorry, O to, sorry, O to E is L, sorry, A, this major axis, length of the major axis, which is half length, semi length, this is OE, which is A. Upper limit is A here, lower limit is L up to this point, so L to A limits. Okay, into pi into y square. Okay, because volume we are calculating, this is pi into y square into dx. Okay, so that is there. Now y square is that value, twice into L to A. Y square here is b square upon a square into a square minus x square. This is a square minus x square. Well, from this equation we can calculate the value of that. Okay, so that is the arc AL. So here we can find out y square upon b square is equal to 1 minus x square upon a square, or y square equal to b square upon a square into a square minus x. This value we have substituted here into dx. Let me now integrate this. So taking this common, twice pi into b square upon a square, let me take outside. It will be integration as a square x minus x cube upon 3. Limits are now L to A. It will give us twice pi b square upon a square. Within the limit it is a square means a cube minus this is L cube upon 3. Then sorry, here a cube upon 3, I'm sorry. This is a cube. Still I'm putting upper limit. This is a cube. A, because x, in place of x we have to substitute a here. A cube minus a cube upon 3, then minus sign L a square L plus sign, this is L cube upon 3 is total value. Let me now further solve it. So it will give us total volume here twice pi into b square upon a square, and here in the bracket these two values are summarized. A cube means 3, a cube minus a cube means twice a cube upon 3 minus, now here it is L cube by 3 plus sign, but a square minus, this is minus a square L plus L cube upon 3. So these are the, this is the value obtained by this arc length. This is the second important point. Let me write here second. This is first volume of the cylinder plus this will be subtracted from the total volume of the spheroid. But volume of the spheroid we have obtained. If I obtain total volume of the spheroid, then what it will be? Here limit will be, if I take 0 to A, then it is minus A to plus A limits if I put. So volume of the, and second thing is volume of the prolate spheroid. Prolate spheroid. What is that? That is revolving the ellipse about its major axis. About its major axis. About major axis. That is the total volume of the spheroid. That will give us limits minus a to plus a. Here minus a to plus a. Let me take the whole. Minus a to plus a is pi into y square into dx. Y square is that value from the given equation. This is twice 0 to a now. Pi, let me take outside. Y square is b square upon a square into a square minus x square into dx from the given equation. Now let me solve it further. Therefore, the volume of the total spheroid is equal to twice pi. Now integration into b square upon a square. This we have taken outside. Integration is a square into x minus x cube upon 3, limit 0 to a now. Okay, it will come out as, because 0 to a limits are there now, twice we multiply, so that is twice pi into b square upon a square into, it will come out as a cube only at 0, it is 0, but only a cube minus a cube upon 3, that means twice a cube upon 3. It will give us 4 by 3 pi into b square. A square cancel out, it is a only. Okay, this is the answer. Total, I mean not answer, total, this is the volume of the total spheroid obtained after a prolate spheroid after revolving the whole ellipse. This minus these two will give us the remaining volume. Okay, that is the point here. This is pi 4 by 3 pi 2 to the 4 b square a. This is the of the spheroid. This is third point. Let me take this minus this. Therefore, total volume, remaining volume. Therefore, okay. I'm sorry, I have rubbed it. This is twice. I'm sorry. This is twice pi into b square upon a square. This we were doing, and here it was twice a cube upon a cube. This is the value here. This is the second part. These two will be added up and subtracted from this. Therefore, total volume, let me write here. Therefore, remaining volume of the remaining solid. This is solution we are calculating. Therefore, volume of the remaining solid is equal to volume of the spheroid. This is 4 by 3 pi b square minus pi into b square a minus sign these two values. First let me add these two. This is twice pi into b square l upon a square into a square minus l square. This is of cylinder, plus this value, plus this third one. This is the total. I mean, we have to solve it now. From this 4 pi b, this minus this, or plus this, these two are to be added up. This is a cube here, 2aq upon 3. Okay, so these two are added up. What is this value? Let me check it. It's 4 by 3 pi b square a minus sign. Now let me multiply them, all of them. It will be twice pi into b square, l into a square is will cancel out. It will be twice pi into b square l only, minus this will be twice pi b square l cube upon a square, second step, plus this value, this one. If I multiply this to a, it will be then 2 pi 2 to the 4, sorry, 4 pi 2 to the 4 pi a cube cancel out, 1a will be there, 4 by 3 pi b square into a. This is the first part here. 4 2 to the 4 here, pi into b square a cube, and this is a square, 4 pi by 3 into b square a. Same value is obtained. This is cancelled out. Alright, then plus this value, minus sign. Here we are still minus sign here, minus. Now a square cancel out, so this is l into 2 pi into b square into l. This twice pi b square into l, a square cancel out. The value plus sign, 2 into pi, this 2 pi into b square into L cube upon 3a square into 3a square. What do we see here? This 4 by 3 pi b square a and this 4 by 3 pi b square a will be cancelled out. And this also cancelled out. This is minus sign and this is with plus sign. So these two are cancelled out. This twice pi b square L cancelled out. Twice pi b square L cancelled out. What about these two? This is L cube upon 3a square. This value is left over. Okay. So these are similar, but let me first solve them. This is upon 3. It is 3 and LCM if I take it is 6, 6 minus 2. 4 by 3. Okay. That is the value. So 4 by 3 pi b square a and this value will be cancelled out. Minus sign is the plus sign here. Twice pi b square L cube upon a square. Minus sign is 4 pi b square a upon 3. This and this cancel out. 4 by 3 pi b square a, and this is with minus sign. Twice pi by 3 into b square L cube upon a square. Okay. Now these two are like terms, but it is 2 by 3. It is only 2. That is the point. So now let me solve it further. The final answer of this, the remaining solid, will be, let me put here, this is pi b square L cube upon a square common. We can take common. Pi b square L cube upon a square common. Within bracket is 2 minus 1.3. It is, sorry, not 2, but 1 minus 1.3. 2 by 3 will come out. It is not twice, but it is only 1 minus, sorry, 1 minus 1.3. This is only 1.3 here. This is 1 times, but twice pi is there. Okay, this is 2 by 3 only. So 2 pi b square. It is b square into L cube upon 3a square. This is also here. It is coming 4 times. Now it is coming 4 times here. So 2, some 2 we have left the 2. It means these two are, if added, it is coming at 4 pi b square, 4 pi b square L cube upon 3a square. 3a square is okay, but twice is not coming. It is coming 4 times. Where 2 is left over. This is 2 by, I'm sorry. This is 2 by 3, but was it twice? Was it twice here? So somewhere 2 is left over. It means twice of this is coming. It is coming at twice of this. That means 4 times. But if I just add them, it is suppose minus sign, and it is added up. It will be then 1 plus 1.3. But that will be 4 by 3. So 3 minus 1. Oh, sorry, this is 4 by, it is plus sign, I think. It is added up then. It is not minus sign, but it is plus sign. If I add them, then it is 4 by 3. It will be 4 by 3. It is, I think, minus sign somewhere is mistaken. If these two are added up, this is 3 plus 1, 4 by, it is 4 by, then 4 will come. So there is some minor mistake of this minus sign plus sign. I might have mistaken. That is only the difference here. This is plus sign here. I'm sorry. These two are added up. This is 4 pi, 1, 3 plus 1, 1 plus 1 by 3. This is plus sign here. I'm sorry. But minus sign, minus minus plus it will be. So that is the only point. Okay. So this is the answer. Question number 12. Okay, we have proved it now. This is question number 12 here. Now 13th question. Question number 13 is of what kind? Let me check it. Now what is question number 13? Let me check it. And that's the last question of this exercise. Okay, 13th question. Question 13 says, show that if the area lying within the cardioid are equal to this and without the parabola this, okay, revolved about the initial line, the volume generated is this 18 pi AQ. Okay, so this is given to us. What is the parabola and what is the ACL? Cardioid, sorry. So that the area lying within the cardioid is R equal to, this is R equal to twice A into 1 plus cos theta. Okay, this is the cardioid here. Now it says between this cardioid and the without the parabola, and the parabola is R into 1 plus cos theta is equal to twice A. Now it says that without this parabola, this cardioid area, volume of the area, okay, this is so that the area lying within the cardioid, this, and without the parabola, this revolves about the initial line, the volume. So this is initial line. So this is polar form. Okay, because initial line says we have to convert this into polar form. This polar form given to us, no problem. So what is the point here? Now it says that this cardioid we have drawn a number of times. Now this is the cardioid here. Okay. Now here this is origin, and this point is, let me take here theta equal to 0 here. Here theta is pi. So that pi, if I substitute here, cos pi is minus 1, so it is 0. R equal to 0 in this case. And here it is R theta equal to 0, it is twice A. This length will be twice A. Okay, now it says that if there is a parabola also, parabola is, suppose this is the parabola here, and this is the parabola. Now this parabola is subtracted. The area of the parabola is subtracted. The remaining is this. Now here theta is equal to pi by 2. So 0 to pi by 2 if I take limits, and this is the theta here. So theta 0 to pi by 2 will take the limits. In case of parabola also, this is suppose A point, this is B point here, or vice versa. If I take A, let me take this is A here, doesn't matter, this is A point because first is cardioid, then the parabola, so this is B point. This is O point we have taken. Now it says that the solid obtained by, or area or surface obtained by subtracting this parabola from the cardioid, then the remaining this area is revolved about initial line, this theta equal to 0 line. Okay, then what is the volume of this remaining curve? That's the point we have to find out. Okay, we have to just find out this. So first we have to find out what is this point, intersecting point here. Theta is 0 or theta is pi by 2 I have taken, but let me take that. What is A point? Theta is what? So if I solve this point A, still I am not solving whether theta is A or something. Let me take this solution. Solving these two curves will give us the intersecting point, the coordinates of intersecting point, or value of theta. What is that intersecting point? It will give us the intersecting point. Intersecting points are what? If I just solve these two, here R is given to us twice A. Value of R, let me equate, is twice A into 1 plus cos theta is equal to, from this R is equal to twice A upon 1 plus cos theta is the value here. Okay, it means twice A twice cancel out. This is 1 plus cos theta whole square is equal to 1. That means 1 plus cos theta is equal to 1, or cos theta is equal to 0, equal to cos pi by 2. Theta is equal to plus minus pi by 2. Therefore theta is pi by 2 here, theta here is minus pi by 2. So intersecting points are these two. Let me take, this is A dash, this is A point here. We have taken this A point. Here theta is pi by 2. So limits intersecting points are of these two curves, this parabola and this cardioid is A, which is at theta equal to pi by 2. So limits we will take 0 to pi by 2. Okay, so 0 to pi by 2. If I put R0, so theta is 0 here, this theta is pi by 2. That's the point. So solid generated by subtracting the volume generated by this arc minus volume generated by this arc, that is the answer. We will obtain volume generated is 18 pi AQ. That is, we have to solve. Now let me find out what is the solid generated now. So therefore, volume of the solid generated by revolving the cardioid A we have taken, this is, let me take C point here, center point, A dash we have taken here, no problem. So by CA, by cardioid, without the parabola, the solid generated is by revolving the cardioid without the parabola about the initial line. That is the point, about the initial line. For the volume in this case, in case of initial line, we say volume generated will be given by, the limits are 0 to pi by 2. We have taken 0 to pi by 2. This is 2 by 3 pi RQ into sine theta, try to understand to d theta. This is for the cardioid. Minus again 0 to pi by 2. Same formula, 2 by 3 pi RQ. It is about the initial line. So 2 by 3 pi RQ into sine theta into d theta. This is for the parabola minus sine parabola. So the two volumes, difference of these two volumes we have to calculate. That's the point here. This point is to be calculated there. Okay, so that is the point here. Now let me solve it further. Therefore, just we have to now calculate these two values. So 2 by 3 pi, in first case RQ is this value,